as we get started. But Toby, if you're ready, whenever you're ready, I think we're ready.
Okay, I'm ready. I'm ready. You guys are ready. We're all ready. Let's do it, right?
Right. Absolutely.
All right, cool. Well, what's up, guys? Welcome. Thank you so much. A huge shout out to James for putting this together, for getting everybody together and spearheading this Altec Birmingham SolidWorks users group. I love the users groups. I love hanging out with you guys. I wish I could hang out with you in person. We almost made it happen, right? I'm coming through town on my way to Texas to do a Texas users group tour next month. I'm gonna be doing 6 different users groups in Texas. So the timing was almost perfect. We were so close. And I would love to have been there with you in person, but I really appreciate this, being all set up and excited to show you guys some tips and tricks tonight. So I guess with that, let's get into it. We're going to talk about some sketching tips and tricks, and we're going to talk about some sheet metal tips and tricks. It's kind of like the agenda for tonight. So a lot of these tips and tricks come from or either already come from, or maybe eventually will find their way onto my YouTube channel. So I run a website, tootalltoby.com, and I also run a YouTube channel with a lot of different tips and tricks. And if you're looking for where to start on this YouTube channel, probably the best place is to take a look at the playlists, because the playlists are a little bit more themed. And what you'll find from those themes are that there's a section called Model Monday Replay. And with Model Monday Replay, that's this section down here, what we've got are 2D prints that you can try to model in SolidWorks. So each one of these is its own exercise. They're just practice models that you can do in SolidWorks. And whenever you click into one of these, what you'll find is that there's a timer that shows up on the screen. So there's a timer here. Once you get into this thing, a little quick intro by me, and then there's a timer here in the screen, and you can kind of time yourself to challenge yourself and see how long it takes you to model this. And then once you get done and you figure out the mass, you can pause it. And sometimes what people will do is they'll actually put their times down here so you can see how fast different people are doing it. So it's a great playlist, a great resource to access if you want to get just some practice models in, going from 2D to 3D. If you're, a lot of times people are looking for that. They're just like, I just need some good 2D prints that I can practice turning into 3D models. And then the other playlist that I would refer you to, and this is one that I'm going to be referencing a lot tonight, is the playlist called Toby's Power Moves. So these are little quick tips. They're usually under 5 minutes long, and they just give you like one more tool to add to your arsenal, to add to your toolkit. And these will be things that'll help you save time throughout the day. These will be things that'll you'll be able to use over and over and over again. So that 3-4 minute investment to watch the video will definitely pay off, and you'll find that you're able to save a lot of time on these. When I first released these, I was doing one every single day. I did that for a month, like kind of as a challenge to myself. And then they kind of taper off, but I'm still releasing them. Like I actually just released one today about how to avoid accidentally renaming your features or going into the rename command in your feature tree, which is kind of annoying if that ever happens to you. So I guess the final thing I'll just say about this, or maybe like the final 2 things I'll say about this is if you're ever looking for some good music to listen to while you're doing 3D CAD, this is just like digital, like synth wave, retro wave music. You can just put on a playlist here and kind of like have that in the background while you're working. And it helps, for me, it helps keep me in the mood. It helps keep me working and being productive. And then we also are hosting a CAD versus CAD tournament. So every Saturday, I take 2 people and I pit them against each other, just purely to entertain myself and have them do CAD against one another. So basically, I show them one of these prints, one of these 2D prints at the same time, and I say 3, 2, 1, go. And then both of the competitors show their screen, and they try to see who can come up with the mass first. So they're actually sharing their screen side by side, and they actually show their screen and go through and try to create these models and come up with the mass. So it's kind of fun to see like how different people have their SolidWorks laid out and different workflows and how they troubleshoot. And it's not just SolidWorks. There's some people who are in this competition that are using different CAD systems as well. So it's kind of cool. If you've never seen any other CAD systems, this gives you a chance to see how other CAD systems work and how they kind of work through some of these challenges.
I'm actually really excited for that, Toby. Saturday, as long as you have confirmed it, I think I'm co-hosting this Saturday, or co-commentating this Saturday on it.
Yeah, I'm excited, man. We're gonna have we're gonna have a good time. We're gonna be there together talking about the competitors, and basically every Saturday we do two matches. So each match should take like maybe 20 or 30 minutes. So ideally the live stream will just run for an hour. This first one that we just did this weekend, the first match took a lot longer, but I think that was just like a little bit of growing pains. So it'll hopefully not be longer than an hour for you and me on this one, James.
Yeah, I ain't worried about it. I ain't got anything to do all day.
Okay, perfect. That's perfect. That's what I like to hear. All right, cool. So as I said, when I show some of these tips and tricks, I'll definitely reference that YouTube page and let you know, like, if there's already a version of that tip on there, so that if you really like that one, you can go back and you can review it. And then the final thing I just want to say here is that I'm also really happy to be working with the guys from SolidBox. What SolidBox does is they help you to avoid running into errors like this when you get into SolidWorks by going through and just kind of creating ready-to-use systems right out of the box. So instead of you having to figure out what's the best way to configure a system for SolidWorks, what SolidBox will do is they'll help you. I mean, first of all, they'll help you come up with the right specifications based on what you're doing, but they actually get the box in-house at their place before they ship it to you. And they go through and they make tweaks to Windows and they make tweaks to the BIOS and they run benchmarks and they make sure that as soon as you get SolidWorks, it's just ready to go. You just take it out of the box and you start using SolidWorks. Sometimes even if you buy the right computer, there's still things that you need to do, like especially with laptops, there's a lot of stuff on a laptop in the BIOS that will throttle the performance of the laptop, especially if you're on a battery. So for example, it'll use like the weaker graphics card, or it'll use Intel Speed Step to throttle the CPU usage when you're on a battery. So they'll go through and they'll make sure that all those settings are tweaked and that everything, all the bloatware is gone. It's definitely not an out of the box Dell system. It's like a legit tuned performance system for CAD and CAM. So if you're ever in the market for a new piece of hardware, be sure to check out mysolidbox.com. They're definitely a great resource and take away a lot of that guesswork or IT work that you might otherwise have to either figure out yourself or have somebody else do for you.
I got a question for you about that, Toby.
Yeah.
Do they only do optimization for CAD, or they do stuff for other workstation needs, like any kind of like maybe photo editing, video editing? You think they do anything like that, or is it just CAD optimization?
I mean, I know that they pride themselves on, having in-house CAD and CAM professional engineers so that they're able to hone in a little bit better on common issues that exist in that space. But I can definitely ask them that question. I'm making a note of it now.
Yeah, I'm just curious. I do some photo video editing as a like a hobby, so I was kind of curious. It would definitely be a workstation thing that it'd be cool to have a workstation that could do both.
Yeah. No, that's a great question. What kind of stuff do you as part of that hobby? What kind of stuff are you like into? Is there like a specific type of photo editing, or are you a photographer yourself too?
Yeah. I started photography back in September. I really do a little bit of everything. I enjoy street photography a lot, but
Okay.
anytime, like, I don't leave my house without my camera now. It's actually in my backpack out at my desk.
Nice. That's cool. Okay, well, I'll definitely ask them about that. That's interesting. Maybe we can talk about that more during the stream too on Saturday. All right, cool. So let's get into it here. I know that was like a 10-minute intro, but I'm gonna make up for it by giving you guys tons of good tips and tricks. So the first tip that I want to share with you, this is definitely my favorite bit of functionality. My favorite thing about SolidWorks really is the ability to leverage the S key in SolidWorks. So the S key in SolidWorks is available on every system. As soon as you get SolidWorks up and running, the S key is available. And what the S key is it's a menu bar that shows up that is context sensitive or mode sensitive, really. If you think about SolidWorks, you could think that SolidWorks exists in really 4 different modes that you could be working in. So you could be working in part mode, assembly mode, drawing mode, and then you can also be working in sketch mode. And so what the S key does is it lets you customize your menu, this menu that shows up when you just press the letter S on your keyboard. And what I mean by customize is you can do a right mouse button here, and from the right mouse button, you can choose to add or remove any commands from the S key. And you can see here the 4 different modes for the S key. So when you're working in part mode, the S key looks one way. When you're working in assembly mode, it looks a little different. When you're working in drawing mode, it looks a little different. And when you're working in sketch mode, it looks a little different. And so some of the things that I've done with this S key are things like removing the flyout menu for line and center line and just replacing them with explicit commands. And similarly, removing the flyout menu for rectangle and center point rectangle and replacing those with explicit commands. So prior to me doing that, there was a menu that had a little arrow pointing down that had a line on it. And then inside of that menu, I could get line or midpoint line or center line. And I think on some systems, you also have infinite line there. Or maybe that's just a check mark option. But I didn't really feel like that was necessary. And, similarly, the rectangle command, I'm sure you guys have all seen the rectangle command when it has that little arrow pointing down, and then you can go through and you can pick all the different types of rectangles. Well, I mainly only use those 2 anyway. I use corner rectangle and center point rectangle. I don't really use the other ones anyway. So instead of having to constantly go into that menu, pull down that menu, and then figure out where the desired rectangle command is, I just said, you know what, I'll just make those explicit commands on the S key toolbar menu. The other thing that I've done here with the S key toolbar menu for sketch mode is I've added the extruded boss base and cut extrude, and then also the base flange tab command because I work a lot in sheet metal. I added those commands as well because that way, whenever I'm working in sketch mode, I can just immediately jump out into a feature mode. So if I make a 2.5-inch hole here, I can S key and then jump right into the cut extrude command. You can see how quick those workflows get when the commands that you're looking for are always in the same spot relative to your mouse. So no matter where I move my mouse, those commands always show up in the same spot. And it just really helps you to get through your workflows. Like I know that the smart dimension command is always going to be right there. So I could quickly get in and then define the location of this hole. And I just know where these commands are going to be. You just kind of start to develop some muscle memory. So that's another shortcut that I'm going to categorize it as a sketching shortcut. I mean, really, it's a shortcut you can use all throughout SolidWorks, but it's definitely a really valuable one. And like I said, some of these are available on my YouTube page. That's one of them I would definitely check out, where you can go in and you can really learn how to customize your S key to take advantage of some of those shortcuts, take advantage of some of those workflows. The S key in SolidWorks is a huge time saver, a real game changer. There's certainly other similar types of commands that you can do here in sketch mode. Like you can learn how to use the right mouse button and drag to bring up what are called mouse gestures. This is another way that you can access some of the most commonly used functionality in your different modes. But for me, it's just always been the S key. So it's just personal preference. I'm sure that mouse gestures work great as well. But for me, I can just kind of really quickly get in here and define my geometry using the S key and just kind of plow through these models at pretty good speeds.
I actually have, for me, I actually keep the S key buried in my mouse gestures.
Yeah, I like that. So you go S key into your mouse gestures, and then that brings up like a sub menu almost. That's cool.
Yes.
Like a menu within a menu. Very cool. Yeah, I like that. So this is what we're going to be covering today. That was just like a kind of like a warm-up tip. This is what we're going to be covering today in sketching tips and tricks. We're going to talk about using the trim command, convert entities, derive sketch, intersection curve, reorder sketch to the top of the tree, sketch colors, and modify sketch. We're combining kind of 2 different presentations here today. And I know that this might seem kind of sparse if it's only 7 items, but I think you'll see pretty quickly that we go in depth and kind of break this apart and talk about multiple subtopics in each of these categories. So for example, using trim, we're going to talk about using trim to extend. We're going to talk about how you can actually backtrack on a trim. And we're going to talk about the convert to construction functionality that was added a little more recently to the trim command. So when we get in here to sketch mode in SolidWorks, we're going to go top plane, begin a sketch, orient the view, S key, and then draw a couple of lines here just at random. And this is a good exercise. You can kind of do the same exercise on your machine when you get back to the office. But one thing to note about the trim command, I mean, I guess the first thing to note is that I typically will use the power trim command. Power trim, I think, is really helpful. And the way that power trim works is that you click and you begin dragging. And then when you drag through entities, those entities are trimmed to closest. So if I was to drag through these lines here, they would be trimmed to closest. So I click and hold the mouse and I begin dragging. And then as I drag through these entities, you can see that they get trimmed away. Now, one thing that a lot of people don't know about the trim command is that whenever you're doing the trim command, if you end up going too far, you can actually backtrack and hit this little red dot, and that lets you kind of back off a little bit. This doesn't come up too often, but there are times when we get a little too over enthusiastic. So like if I wanted to just trim through maybe these first two lines and I accidentally hit the last one, well, it's good to know that you can backtrack with the trim command. You can kind of just go back over that. Maybe your intention was to go down this way and you just took that turn a little bit too wide, right? So as you were coming around here, you were like, whoa, oh, wait, no, I didn't mean to get that. So you just backtrack over that and then you can go down through there. Another thing that you can do with the trim command that I use all the time is the ability to click and drag and extend. So the trim command is not only limited to doing trims, but you can also use the trim command to extend. And I find that to be extremely useful when you're creating regular sketch geometry, but especially when you're doing like a convert entities and then you create another line outside of that convert entities region and you want to extend it. That's a great place that you can leverage that functionality. So for example, here, if I was to begin a sketch, orient my view, maybe I'll just sketch a line out here that's a little bit further out, and then I'll take this face here and do a convert entities. Well, I'm going to, maybe delete this line here and then S key trim, and then I'm going to take this line and I'm just going to extend it out. Just take this and extend it out. So that's a really handy bit of functionality that's built right into the trim command, is the ability to both trim and extend from that one single command.
What are you doing to extend while you're in the command? Just click and drag?
Click and drag, you got it. Yep. So just click and drag, and that lets you extend. Now, there is a little bit of a kind of like a cool bonus functionality that happens there, which is if normally if you click and drag, what'll happen is it'll extend that line up to the next line that it would, normally intersect with. But what you can also do is you can click and drag and you can click it onto a line that it's not intersecting with. Now, this is a little bit of an additional workflow. So I'm clicking and dragging up to this line here. Then I'm going to let go of my mouse while I'm over that line. And then I got to click that line again. It's a little bit awkward, but it does extend it and it does create the coincident relationship. So if this line were to change its location, they're hooked together now. So I'm just going to Control Z to undo, and then I'll show you that again. I click and drag this line over here to this line that it would intersect with. Then I let go of my mouse, and then I click again on that line. So you can actually extend it not only to lines that it would normally extend to, like this line here, but you can also extend it to lines that would have a virtual intersection. So if I was to maybe do something like this, you can also just extend it out to space. So I can just like click this here and drag it out into space. At that point, you may as well just drag the endpoint, right? You don't really need to do that, but it's just good to know that you can do that. But then with this line here, if I wanted to click and drag over here to where the virtual intersection would be, let go of my mouse and then click again, and then there we go. You can click and extend to the virtual intersection. So trim is very helpful, and in the newer versions of trim, there's also these options down here that help you with regards to construction geometry. This one I really like: keep trimmed entities as construction geometry. There's been plenty of spots where I've used this where, I've already got a bunch of existing relationships to the line, so I don't want to completely eliminate that line with a trim. So I'll just use this option here: keep trim geometry as construction, and then anything that you trim through remains behind but remains as construction geometry. So I think that one's really handy too. If I have a bunch of sketch relationships over here to these segments of the entity, I don't want to actually completely eliminate them. And if there's any other questions along the way, please feel free to ask. I have a Q&A section, established at the very end of the presentation, but I prefer to just answer your questions as you think of them, right? Because otherwise you're going to forget them by the end anyway. And then they're just going to go into the ether and we're never going to get that value back. So any questions you think of along the way, just let me know.
And I am monitoring the chat, Toby. So if anybody virtually has questions, I'll stop you and let you know.
All right. Awesome. Thank you for that. Okay, let's move on to the next topic: convert entities and the soft relationship. So what I mean when I say convert entities and the soft relationship is that whenever you do a convert entities in SolidWorks, the default behavior is that the converted entity will adhere to and honor the existing geometry. And so I'll illustrate that here with this part. Let me just change the color of this part just to make it a little easier to see that sketch. So I'm just going to go into appearances here and make this like a high gloss plastic. So there you can see that sketch line. It's a gray, that gray sketch line there. And I'm going to go to this original underlying geometry and change the underlying geometry here to 6 inches. And what we can see is that that sketch line honored that change, right? The edge increased in length, and so the sketch line honored that change. It increased in length. We can also see that the sketch line is fully black, and we can see down here that the sketch line is fully defined. But relationship in SolidWorks, because it only remains intact until you grab one of these endpoints and you drag one of these endpoints. So if I grab this endpoint here and I drag this endpoint, we can see that I could actually drag that off, and that endpoint became blue, and the sketch now changed to underdefined. So a different way of illustrating this is if I create a couple of circles on the top plane. So I'll create a circle here with a diameter of 1 inch, and I'll bring that out to a height of 1 inch as well. And then I'll go top plane again, and I'll just make a construction line here. And then I'll say that I want this to be 2 inches in diameter, and I'll want that to come up to 1.5 inches high. Now we've got these 2 circles here, or cylinders, and I'm going to go to the front plane and begin a sketch. And so from the front plane, if I was to take this edge and convert it, it turns it into a line. And if I was to take this edge here and convert it, it turns that into a line as well. And so what we'll see is if we were to go back to the original geometry and maybe change this from 2 inches to 1 inch, that line, honors that sketch relationship. But if I was to edit this sketch here and just grab these endpoints and move them around a little bit, now what we'll see is when we make it that same change, if we change this from 1 inch back to 2 inches, we see that segment of the sketch is now no longer honoring that relationship, where this segment of the sketch over here still will. If I make that 0.5, it still will. So this is just a nuanced thing. I mean, it's not so much there's a specific practical application, but it's just kind of good to know about. Like all 4 of these lines here have convert entity relationships on them, and the whole sketch is black. And if I take this line here and I delete the convert entities relationship, so the line itself is still there, but the convert entities relationship is deleted, I can now click on that line and just drag it over. And see, now it's no longer fully constrained or fully defined. Before I did that, I would basically be in the same spot I was in a moment ago, where this face in any way, all the edges would move right with that face. But after I grab that and drag that off, I've kind of broken up that soft relationship. So it's like a temperamental relationship. It's like it stays and it honors that relationship until you manually do something to break it apart, until you mess with it. Once you mess with it, then you break it apart, and then it's no longer going to honor that relationship. So that's kind of a cool. Yeah, please.
Does this convert entities, does it only work in parts, or can you do that in assemblies as well, to like make a new part in an assembly based on the geometry of another part?
Oh yeah, you can absolutely do that. You can absolutely take the geometry from one part and then use convert entities to drive the geometry of the other part. The only thing you got to be careful of when you do that is that you're now adding to the complexity of the overall design. So when you do that, it's gonna hold on, let me bring up a file here. So when you do that, it's gonna put you in a spot where you're now actually hooking those 2 parts together, and they're going to be related, and then that creates kind of an additional layer of potential complexity to the design.
Yeah, but you can delete those relations, right? As long as that sketch is defined, within its own part. Eventually, I may be overthinking this.
No, you're right on point. I mean, yeah, and the short answer is absolutely. You can absolutely eliminate those relationships after the fact. Yep. So if I was gonna create some kind of a cover plate for this region down here, I could go into insert component, new part. I could give this part a new name, cover plate, plastic, something like that. And then I could say that I'm going to create my sketch on this face. Now, as soon as I do that, I'm already creating a relationship between the 2. because now the location of the first plane is dependent on the location of this face here. But just putting that aside temporarily, now I could do a convert entities, maybe convert the interior loops as well, and then bring that out to become some type of solid geometry. And what we'll find is when we do that and we open that part into its own window, we have this feature in the tree that displays as a minus sign and a greater than sign. And whenever you have that feature, that's telling you that you have what are called in context relationships. It's telling you that this part is not just a standalone part. It's got a relationship to something outside of this part. And so, you just have to be careful. Like if you're working alone, the stakes are lower. And when you're working with a team, the stakes are higher, right? Because if you're working alone, you can probably keep track of those relationships a lot easier than if you're working with a team. When you're working with a team, now everybody on the team has to kind of know what's what. And a good way to do that is just kind of leave love notes for one another. That's why I call them love notes. So like in the tree here, I might call this like base shape, and then I'd say like converted from bridge, something like that, so that people will know like, hey, be careful. This is this feature is converted from somewhere else. And you can also right click on the feature and you can say edit in context, and that'll automatically take you back to the assembly where that relationship was created from. Or like you said, you could get in here and you could start editing the sketch and trying to get rid of those relationships. So you could delete all those converted entity relationships. I could say delete all, get rid of all those convert entity relationships, and then we can see if that little minus sign greater than symbol goes away. And if it does, then this part is no longer related to something outside of the model. So yes is the answer to the initial question, and then there's a little bit of an explanation of how after you do that, you just need to advance with a little bit of caution. I mean, it's like magical that SolidWorks has full associativity between files. It's incredibly powerful that you can change one part and have other parts update. But it's like it's like any complex system. It comes with an element of responsibility, right?
Yeah. I just wasn't sure because when I saw you doing that, it reminded me, I used to work at NX at a previous employer and they had a similar function, but I didn't know SolidWorks could do something kind of like that. That's why I wanted to ask. Thank you.
Yep. Great question. So that's a little discussion of convert entities and the soft relationship. And I just want to also talk about convert entities in an entire face here real quick. This is just kind of a good little reminder of the power of SolidWorks. So if we look at this geometry here that we just created and we select this face and begin a sketch, and then let's say I take these edges here. So I'm picking each of these edges, and then I'm going to do a convert entities, and I'm going to take that geometry and I'm going to extrude that out as a new boss extrude. So this time I'm going to come out to 2 millimeters and I'm going to add some draft to that boss extrude. So let's make this 13 degrees of draft. Okay. 14 degrees of draft. So there we go. You see how that's got that nice little bezel going around the outside there. I think that looks pretty good. So now I'm going to roll back in the feature tree, and once I roll back in the feature tree, I'm going to take this geometry and I'm going to manipulate it a little bit. I'm going to change it. So I'm going to add a cut extrude going through this geometry like so. And then I'm going to roll forward. And when I roll forward, you can see that the convert entities kind of ignored that cut extrude. And I also ended up with an error in the sketch for that geometry that I did the convert entities on. So now I'm going to basically do the same thing, except that when I go into this sketch and I go to do the convert entities, I'm not going to pick all the individual edges. I'm not going to go edge, 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 edge. Instead, I'm just going to pick the entire face, and then I'm going to do a convert entities. So pick the one single face, do a convert entities, and now I'm going to roll back in the tree, and I'm going to create that same cut extrude again. So we do extrude cut here, and then I'm going to roll forward. And this time you can see that the convert entities actually picked up on that change to the topology of that geometry. So it's the point that I'm trying to convey here is whenever you decide you want to use convert entities, you're going to have an option to convert edges or faces, right? You can convert the individual edges or you can convert the entire face, and you're going to get a different result. If you convert the entire face and then you make changes to that face, the convert entities will honor those changes. It still uses what's called a face loop. It uses all the exterior edges from the face in order to generate the geometry from the convert entities. And a lot of times that's a better result. A lot of times that's more in line with the result that you want. I mean, it certainly depends on what you're building. But most of the time, if you change the perimeter of the face that you did the convert entities from, you probably want the convert entities to reflect that change, even if it means injecting 2 additional edges, because I added this edge and this edge here. But it's a good, just a good reminder of the difference between convert entities by picking edges versus picking the entire face. And then I just wanted to talk to you for a minute about derived sketch. So this is another topic that lands in this category of advanced sketching tips and tricks. And derived sketch is a little different from convert entities. So far we've talked about convert entities, and with convert entities, what you could do is you could create like this, where you've got a little, little platform here like so, and then you're going to go to this face, you're going to begin a sketch, and you're going to create a sketch that looks like an arced tombstone, something like this. And then you're going to exit that sketch, and you could go to a different sketch plane. You could begin a sketch, and you can actually take that sketch geometry and do a convert entities. And so now you have the same geometry back here as you have up front. And you could maybe go to this original geometry and change it a little bit. And you're going to see that geometry in the back changes as well, within reason. There's some changes you can make that are not carried through. So for example, if you were to create an additional piece of geometry here, well, that's not going to carry through, right? Because you only converted these sketch entities. You didn't convert all of this geometry here. And certainly if those two sketches are not in line with one another, this isn't going to work. And so this is where we can introduce a different piece of functionality, and that functionality is called derived sketch. So the way the derived sketch command works is you pick a plane, you hold control on your keyboard, and you pick a sketch. So I've come over here to the tree, and after holding control, I picked that sketch as well. So you pick a plane, hold control, you pick a sketch. And once you do that, you can go into the command insert derived sketch. That command actually won't be available if you don't make that pre-selection of a sketch and a planar face. So you notice here, if nothing is selected and I go insert, derived sketch is actually grayed out. But if I pick a plane and an existing sketch, I can do insert derived sketch. And derived sketch is kind of cool. You'll see that I can move this around, and I can lock down this point, and I can begin rotating the sketch, and I could take this line here and say that it's supposed to be horizontal. Well, that's kind of weird. Like, that's a little bit of a strange behavior. I said horizontal, and it became all black, and it even looks like I can kind of still move this point. Like, it's really bizarre how that's working. Okay, well, why don't I take this point, and I'll also make this point coincident here on this line. Okay, now it's fully defined again. Now it actually truly is fully defined. And what we'll see here is that I can't create any additional sketch geometry. I can't make any new lines. I can't make any new arcs, can't trim, can't do convert entity. All these sketch tools are blanked out, right? And the reason why is because the derived sketch will always be a direct reflection of this original sketch. It's almost like we're doing quantum physics here with this, right? We've got like quantum entanglement between these two sketches. I don't know if it's too early in the week to be talking about this kind of stuff, but basically what I mean is that any changes that I make to the original sketch will show up on the new sketch. Even if I was to inject additional geometry in the original sketch or remove existing geometry from the original sketch, it'll all be reflected in this new sketch here. And so the benefit of having a sketch situation like that comes up when you're doing kind of complex lofting, where you are trying to create multiple profiles that are not necessarily in line with one another, but you want them to all behave the same way. So let me show you an example of that. Let me just grab the file here. Here we go. So here we can see that I'm going to create some kind of like a housing, some kind of a vent. Maybe this is some type of like an HVAC vent, something like that. And I want this thing to rip around the corner here. Well, what I could do is I could go to, I've got my first profile here. Profile 1 is here at the end. Profile 2 is here kind of halfway in the middle. So I'm going to go to this third profile plane. I'm going to hold control and choose profile 2. And I'm going to say insert derived sketch. And so that drops that derived sketch right in line here. Now, all I need to do is add the relationships to lock this down. So I'm locking it down to the path and to the guide curve. And then I'm going to do the same thing with my original sketch profile. So I'll take this first sketch profile, hold Control, choose a sketch plane, insert derived sketch. And then once again, I'm going to lock that down because it's still free to kind of just like float around and move anywhere. So I'm going to lock it down to the guide curve. And then I'm also going to lock it down to the path here. And now I'm ready to create a somewhat complex loft. So I'll go here to solid loft feature. I'm going to loft from this profile to this profile to this profile to this profile. And then I'll say that I want that to follow the path and the guide, or the two guide curves. And so now, if I was to go to any one of those two, leading profiles and say that I want to make a change to them. So if I was to say I want this to go from 60 to 80, well, it not only changes in the starting profile, but it also changes here at that ending profile. Let's say that's too high. I want it to come down to 70. You'll notice it changes in both spots because that derived sketch, because that quantum entanglement, right, between this first profile and this last profile is set up so that if one of them changes, the other one automatically changes right along with it. So if this was to grow to 80, we see that both of those profiles update to 80. So it's a pretty cool bit of functionality, the derived sketch. There's a lot of applications for it, but I think that's probably the most common one. But there could certainly be other applications, like if you were doing a machining type of a scenario and you wanted there to be a flange here and you wanted there to be a flange here, and they're always going to be the same, or you wanted one of them to be at 90 degrees and they're always going to be the same. That would be a great application for a derived sketch as well. You just would then extrude this one in direction one, extrude this one in the opposite direction, and then extrude the one that's going around the corner. And it does work downstream with multiple copies. So if I was to take this sketch 2 here, hold Control, choose this face, and say insert derived sketch, now I've got an additional version of this thing. And maybe this one is supposed to be hooked onto this corner, and then it's supposed to be rotated around like this. So it does work downstream, with multiple instances of that. And then I could boss extrude all 3 of these. And if one of them changed, if this one changed, they would all change automatically.
Does that have a scale functionality as well? Like, say if you wanted one copy of one sketch, but take everything and just scale it down some, does it have that functionality too, or just
not in derived sketch?
Okay.
Yeah, you're not gonna be able to do that with derived sketch. Once you create the derived sketch, it's gonna automatically be the same. Yeah. I mean, I guess with something like that, what I would probably do is features boss extrude, and then bring this out to whatever the height's supposed to be, and then here, uncheck merge result. So I'd say don't merge the result, hit the green check mark. Now that is its own body. And so that means I can go into insert feature scale. And then I could say I'm going to be scaling here. Let's see. I wonder if scale is still going to try to do that's interesting. I thought that scale would let me do it just with that body, but it almost looks like it's trying to do it to the whole thing. So, well, let's see what happens. It did just do it to that body. So that's cool. It's interesting that I thought. Oh, yeah. It does. I'm sorry. What am I saying? I did pick a body here. Yeah. So pick a body or bodies. So then it would just be a matter of creating the coordinate system where you want the scale to take place. So you would go insert reference geometry coordinate system, and then drop a coordinate system here. And then you would go to scale and then say you want that to scale about the coordinate system, and then pick this guy here.
Nice.
Yeah. So that's probably how I would do it. And then once you're done there, then you could combine those bodies back together. So definitely
in that particular instance, what happens if you change that original sketch? Is it still derived?
Yeah. It's going to push through to everything. So if we go back to this one here, let's just say we make this one a little bit wider, then it pushes right through to everything.
It just keeps that scale. That makes sense. Okay, yeah.
Yeah, because the scale came after the derived, essentially.
That makes sense.
Yep. Yeah, pretty handy, right? A lot of people don't know about that one, but I mean that's why you come to the user groups. You get to learn about all these cool little nuanced hidden gems in SolidWorks. So the final thing, or as we get into this final section here, I just want to talk to you a little bit about comparing models and reusing sketches. This is something that we do a lot of in SolidWorks. You know, you maybe get an imported model and you want to work with that imported model, or you've got an existing design and you want to use sketches to see how the new design compares to the existing design. And I just put together a couple of tips to help talk about that topic. So the first thing I'm going to talk about here will be used in just a moment, but I want you just to understand that this is a thing and kind of understand how it works. So I'm going to come in here and I'm going to create a circle. I'm going to create another circle here that's exactly horizontal to that first circle, but it's a little bit different diameter. And then I'm going to create another circle here that is exactly the same diameter, but it's not in line horizontal or anything. And then I'm going to do a right mouse button. And from the right mouse button command in sketch mode, you can choose fully defined sketch. And what fully defined sketch does is it adds sketch relationships and sketch dimensions to your sketch to ideally or intentionally turn it into a fully defined sketch. It doesn't always work. It doesn't always get everything in order for it to be technically fully defined, but it still presents a lot of value, particularly when it comes to the relationship. So, for example, there's a relationship here of equal. And if I turn that relationship on, then these two circles will be hooked together as equal in size. There's a relationship here of horizontal. And if I turn that on, then these 2 points will have a relationship added that makes them horizontal to one another. So if we say calculate here, so if I turn that on, so, you know, all these relationships are on pretty much. If I say calculate, you can see what the result is. SolidWorks goes through and adds the dimensions. The dimensions come from a datum that you specify down here. And the relationships are based on what you choose to include or not include. But you can see here that the result is that you end up with these two entities here being equal. But you also end up with these two entities being equal. The line up top is exactly equal to the line at the bottom. So it added an equals relationship there too. And, you know, that's probably not what you want. That's actually why I usually turn equals off, because it usually gets like extra stuff that I don't want to be equals. So now let's take a look at a practical application of this. And this is going to be in using the intersection curve. So again, the scenario here is that you've received a model from somewhere and you want to now work with that model in SolidWorks. And maybe that model is a step file or an imported file, a file that maybe doesn't have a tree, or maybe it's a model that does have a tree. You know, this model here has a tree, but it doesn't have to. I mean, this could just as easily be a model that does not have a feature tree. It could be an imported step file. Front plane, which is running right through the center of that model. Front plane, begin a sketch, orient the view. So front plane, begin a sketch, orient the view. And then underneath convert entities, we've got a command here called intersection curve. Intersection curve. And what intersection curve lets you do is it lets you grab the geometry of the part where, or of faces, where they are intersecting with the current sketch plane. So I go in here to intersection curve and I pick this face and this face and this face and blah, 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 all the way down. Usually what I would do in that spot is just right mouse button, select tangency. That way it just gets all the faces that are tangent. And maybe I'll pick this face and this face as well. And then I'm going to hit the green check mark. And you can see that what SolidWorks did there was it grabbed all the geometry wherever it happens to be intersecting with my with the faces that I selected and the current sketch plane. So now what I could do from this imported step file, hypothetical imported step file, is I could get rid of the 1/2, create a center line, window select, and then Control C for copy. And now I could go into a new part document. Actually, I think that part was originally in inches. And I can go front plane, begin a sketch, and then I can Control V for paste. So now I've pasted that geometry down. And now from here, what I could do is a move entities. Everything's already highlighted. Start point here, end point here on the origin. And then finally, I can finish this up by doing a right mouse button and doing a fully defined sketch. Because right now, that geometry that I captured from that imported model, it's just totally loose, just all over the place, right? None of my relationships, particularly the tangency relationships, are not there. So I can do a right mouse button, fully defined sketch, and I can say that I want to capture, you know, all the relationships that I've got shown here, including tangent. That's a really helpful one in this spot, including horizontal, including vertical. So this is going to become vertical. This is going to become horizontal. And then for my dimensions, I can actually say that I want this to use center line dimensions. So I can say that I want my dimensions to come from here as centerline dimensions, and I say calculate, and you can see that SolidWorks goes through and it actually adds the tangency relationships here. So now this is going to behave with tangency. It added an equals relationship. It even added a 2x there to the dimension, which is pretty cool. It added, all the expected dimensions, and now I'm ready just to take this sketch and turn it into a revolve. So if you're ever working with imported geometry, learning how to use that intersection curve command can be really useful because it lets you take that imported geometry and it lets you turn it into actual standalone geometry. And there's plenty of other spots where that's useful too, like on geometry like this, where you've got an intersection curve. I mean, what the intersection curve lets you do is lets you calculate geometric values. So if I was to open up this part here, and let's say, I wanted to know what the distance is at a certain height of this cup. Well, what I could do is I could take the top plane, hold control, and drag the top plane to whatever that height is, or maybe offset from the bottom of the cup to whatever that height is, hit the green check mark, begin a sketch on that plane, and then use intersection curve, and then pick this face here and say green check mark. And now I've got geometry that I can actually measure. So now I've got an actual, piece of sketch geometry there that I can measure or use for a design review meeting. I can tell my coworkers like, hey, this line is, you can see it down here, 84.7 millimeters. So intersection curve is really useful. It's got a lot of different applications and definitely a good one to learn about. The other place that I use intersection curve a lot is when I'm going to be making a subtle design change, and I want to see just how much of a design change we're really talking about. So if I go here to front plane, begin a sketch, orient my view, and go to intersection curve again, I could take all these faces here that are kind of running down around the outside of this model and hit the green check mark, and that gives me new sketch geometry wherever those faces are that I selected. So I've got this basically, I just kind of traced the geometry of that model wherever it's intersecting with the front plane. Now, at this point, what I want to do is make some changes to the model, but I want to keep track of my before and after version of this model. So what I can do is I can go into this icon up top here, display delete relations, and I can say delete all of the sketch relations that currently exist in this sketch. So delete all, get rid of all those sketch relations. And the reason that I did that is because now that this sketch here is no longer related to any of the geometry in the model, I can take that sketch and I can drag it up to the very top of the tree. See, before I wasn't able to do that because of the sketch relationships. But once I deleted those relationships, it's basically just a blue underdefined sketch. It's not related to anything. So I can take that sketch now and drag it all the way up to the top of the tree. And then I can do right mouse button on that sketch and say sketch color and just change the color to something that really pops out, make it easy for me to see. And then I can maybe sit with the customer and do a design review meeting and say, what if we made this 76 instead of 77? What if we made this 95? What does that actually look like? And how does that compare to what we had before? And it just gives a real nice visual reference. This is where we were before. This is where we were before the bottom. This is where we are now. And so very useful application of intersection curve and also of examining your sketch entities, deleting them, and then rolling that sketch back up to the top. Just really makes it easy to get in there and make subtle tweaks to the design and kind of keep track of what those tweaks did. Any questions on that?
More just marveling at its brilliance.
Cool. All right. Awesome. Well, thank you. And so we talked about display delete relations there. We talked about reordering that to the top of the tree. Very, very useful. We also talked about changing sketch colors. You've seen this a couple of times now, like when I was doing that loft, I changed the colors. Changing the sketch colors is another really handy bit of functionality. You just do a right mouse button in the tree on a sketch, and then you go to sketch color, and you can change the color of that sketch. And then this is something that you asked about a little earlier. I didn't know you're going to ask about it, but I'm glad that you did because now we can talk about this too. Is it possible to actually scale a sketch? And the answer is yes. And you can not only scale the sketch, but you can also scale the sketch dimensions, which a lot of people don't know about. And so if we created a bit of geometry that looked kind of similar to what I just had on screen there. So if I created something that maybe looked like this, so I'm going to come over here 80, and I'm going to come up and then create my line arc line. That's another bit of sketch functionality. I did originally have that in this presentation, but I just took it out for sake of time because a lot of people know about that, the line arc line. Maybe I'll do a lot of times I'll just draw a line here instead of doing the right mouse button select midpoint, just because it gives me a visual cue that that's how my geometry was locked down. And then I will finish this thing off with a radius up top here of 20 millimeters. Okay, so there is our sketch. Now I'm going to do a window selection, Control C. I'm going to exit that sketch, and I'm going to go to the front plane again and click and Control V. Now you'll notice that this sketch is self-contained, but you'll also notice this sketch has 0 what are called external relationships. Earlier in the presentation, we talked about defined in context. That's when you're associating to a different file. But external simply means that there's a relationship between the sketch and something else. Like if I dropped it on the origin here, now there's an external sketch relationship. And you can actually filter these sketch relationships up here. So when I go into that display delete relations command, there's a pull down menu here where you can filter which relationships are shown. And so I'm going to filter for external relationships only. And you notice that there's only one. It's that relationship that I made to the origin. So I could delete that, and now there are 0 external relationships. And I mentioned that, and I know I mentioned it kind of quickly. I do have a video on this topic on my Power Moves channel, but the topic that I want to talk to you about is called Tools, Sketch Tools, Modify. And in that video on Tools, Sketch Tools, Modify, if you're taking notes, this is what you want to write down: Tools, Sketch Tools, Modify. And in the video that I made where I talk about this, I also remind you that you can't really have external relationships for Tools, Sketch Tools, Modify to work. But once you go into Tools, Sketch Tools, Modify, there's lots of cool stuff that you can do with the sketch. Like you can left mouse button and drag to move the sketch around. You can make a mirrored version of the sketch. So if I was to click to right mouse button here on this icon, it actually lets me make a mirrored version of the sketch. So it just like flips it for me without having to actually do a mirror, but it retains all of the dimensions and relationships. And you can even get in here and do a scale factor. So if I made this a scale of 1.5, we'll see what happens to that 10 millimeter diameter circle. And so it not only scales up the geometry, but it actually scales up the dimensions as well. This is functionality that you will not get from this scale command here. This scale command, it'll lock you. If you have sketch dimensions, it just locks the scale on those entities. But the modify sketch command can actually do it all. It's an amazing command, a very old command. It's been in the software forever, and it actually will let you scale up with the dimensions and scale up their dimension values. So modify sketch is epic and definitely worth looking into a little bit. And that's going to bring us to the end of this part of the presentation, the advanced sketching tips and tricks. And it's going to give us a chance to move into some sheet metal stuff. If you guys are still hungry for sheet metal, if your brains are full, we can hold off. But
hey, I have a real quick question. Can I ask a question before you get off sketching?
Yes, please.
Do you ever share sketches?
So
like working between features?
Yeah, so share sketch is a very powerful bit of functionality, and some people really leverage it a lot. I don't use it that much. I use a different technique, but I'll show you both of the techniques here. So the shared sketch technique might be used to do something like this. Let's say we make like a 40 millimeter diameter circle here, and then we create a rectangle here. So then we'll make midpoint, and then we'll create. Here's something that's kind of cool. If I do, if I type in a value here, like let's say I type in a value here of 14, enter, and then I just don't type in anything there. So if I just press enter there, it knows to automatically make that a driven value. I was actually hoping I was going to get a different different bit of functionality. So I'm gonna leave it at that. I'm not gonna go into depth on that because it didn't do what I was hoping it would do. Sorry. Shot from the hip and I missed that time. Sometimes that happens, right? But you still gotta take your shots. All right, so now I'm gonna do extrude, and I'm gonna extrude just a region of this sketch. So I'm gonna take just this region here, and I'm gonna extrude it up as kind of like a rear wall on this design. Sorry, a base wall in this design. And then I'm going to go back to that sketch again, and I'm going to single click on the sketch, and then I'm going to go up here to extruded boss base, and I'm going to take this region here and this region up top here, and I'm going to extrude them. So the same sketch, the one single sketch I'm using to create that second extrusion, then I'm going to take that same sketch again, and I'm going to do a cut extrude, and I'm going to pick this circular region that I made, and then I'm just going to kind of cut that into the model a little bit like so. So that's the shared sketch technique, and it works. I have no problem with it, and I've seen people execute it to perfection, and it's, it can be really helpful, and it definitely works. For me personally, what I usually do is more of a layout type of approach. So if I know that I'm going to have a model that's like going to be pretty complicated, and I want to anchor everything down to one sketch, I'll usually just make some kind of like a skeleton sketch. So for example, if there were going to be multiple heights in my sketch, I might create a single sketch like this, and then have a construction line for each of the heights. And then when I do my extrusions or my cuts or whatever, I'll have them go up to vertex, and I'll pick these points here as the terminating location of those features. And then that way I know that this is like the master sketch that's driving that part. This is a little bit old school, I admit. And it's just, the way you asked the question was like, do I use shared sketches? I honestly don't. Personally, I don't really use them that much. But I don't have any problem with them, and they work fine. And they can be a nice time saver and give you one single point of truth, which I'm always on board with.
We're definitely going to see a lot of that shared sketches Saturday, aren't we, Toby? That's something speed modeling that.
It depends. One of the guys who was doing the speed modeling this past weekend, he really leveraged it. He put on like a clinic on how to use shared sketches, and he was so fast.
Yeah, he was on fire. That was quick.
Yeah, but other people don't, and so it's just I don't have any problem with it. I just personally don't do it. All right, cool. Oh yeah, that's right. I think I have these slides out of order. Let me fix that real quick. Can't have those slides out of order. There we go. Yeah, so I do have a video that talks about modified sketch and how you can use it. Okay, so let's get into a little bit of sheet metal stuff now. So we're gonna talk a little bit about sheet metal, just 3 topics here: the basics of sheet metal, how to make a flat pattern, and then working with imported sheet metal. And I think of these 3, the third one is going to be the most important. That's where I'm going to put the most focus. So let's just first talk about some basics of sheet metal. When it comes to sheet metal, you're taking an existing flat piece of physical metal, and then you're forming it into a shape. And when you do that forming, you get deformation. So on this illustration here, we can see that the deformation is taking place in the corner where the bend is happening. And what I mean by deformation is you are going to end up with a different final length than the sum of all of the lengths in the form. I mean, that's really like the best way to visualize it. So if I go here to window, close all, just to close everything. If I go here to a new part in inches, and I say front plane, begin a sketch, orient my view, and I take 2 lines like this, I'll make this line here 0.5. I meant to make that longer, and 1, and then I go to a base flange. So now I'm going to bring this thing out into the Z as a actual sheet metal part here. So turn this into a sheet metal part. What we will see is if we take the measurement of this line and this arc and this line here, the total length of those 3 is 36.737 millimeters, 36.737. But if we then go into a flat pattern and we look at the total length of that edge, it is different. It is 38.533. So you get a deformation of the material. You're actually stretching and compressing the material depending on which edge you measure. If you measure the inner edge, you're compressing it, and if you measure the outer edge, you're stretching it. Okay, so that's just a real quick basic primer of the physicality of sheet metal. In SolidWorks, the way that gets calculated depends on an option that you specify in the bend region itself, and you also specify this for the entire model. The most common way that you calculate that is with what's called K factor, because it's very diverse, and it can be used in a lot of different scenarios. But there's also what's called bend allowance and bend deduction. And this bend allowance and bend deduction, these typically come off of a static table. So I used to work in a shop that had a chart on the wall that told me that if I'm working with this material, with this wall thickness, anytime I make a 90-degree bend, what I should do is I should take the measurement from here to here. So take this measurement, we'll call this X, and then X, and then take this measurement from here to here. So again, to the sharp. So we'll call this Y. So take this measurement here, and then subtract a third value, which is Z. So X plus Y minus Z equals the flat. And that's called a bend deduction table. So you figure out what your distance is to the corner, and then you subtract that extra amount. An alternate approach is called a bend allowance table, which basically works the same way. It's just you take the measurement from here to here, you take the measurement from here to here, and then you add Z, whatever Z is, you add that to those two measurements, and that's called your bend allowance. So bend deduction, bend allowance are not nearly as diverse because it's dependent on a specific material thickness, and it's also dependent on this angle being 90 degrees. So if we compare those methods to K factor, what K factor does is it actually takes an arc length at a ratio into the material. And this ratio is halfway through the material if the K factor is 0.5. So that arc ratio would be, you take whatever the wall thickness is over 2, and that gives you the arc location that you're going to calculate the arc length for. If sometimes the K factor is like a third of the way through the material, so it'd be 0.333, or 2/3 of the way through the material. This is something that people figure out in the shop, and a lot of times it takes them back and forth, and it depends on not only the thickness but also the material and the brake press that you're using, or whatever the machine is you're using to bend. But the nice thing about K factor is it is not dependent on the angle of the bend. So once you get your K factor dialed in, it will typically work on non-90 degree bends. Now that's a subjective statement, because depending on how much bend you're doing, that can also have a significant impact on the deformation that you can expect. So it's more like if the bend is 95 degrees or 85 degrees, it'll still work. If it's 80 or 100 degrees, it'll still work. But then when you start going beyond that, maybe you get into a little bit of a gray area.
So your K factor isn't equal. It's not essentially the median value arc length of the part.
It's a ratio that is defined here in the bend in SolidWorks. So you actually define the K factor. So if the K factor is 0.5, then it is exactly through the middle. Okay. But if the K factor is 0.3333, then it's a third of the way into the material. Or if it's 0.66666, then it's 2/3 of the way into the material. And
you change that K factor, and your flat pattern is going to change, even though your bent formed metal is going to stay the same.
I learned that today because about 8 end panels on a 2013 body had the custom K factor allowance removed because they were all wrong.
The main thing to take away from it is the K factor is a ratio. So that being between the curve with the number, in this case 0.33, is a third of the way in set. So
I had always assumed the K factor was always the median line on the bend, but
it's a ratio here, and you can validate these. You can test these yourself if you just do a sketch and then you do an offset entity. So if this wall here is I don't know why I made it that value, 2.286 millimeters. I don't know why I made it that. But if that
you did it in inches.
I did it in inch. Oh, okay, yeah, okay, thank you. So yeah, this should be in inches. My measurements are still coming up in. See, that's something that this gets a little nuanced, but in evaluate measure, if you have your unit set here to custom, then like you'll get weird results down there. So this is in inches and it is okay. So it's 90 thou in inches. So if we go here, we say begin a sketch, and then we take these 3 lines here and we do offset entity that to 30 thou, to 1/3 of the way through the material thickness. And then we take a measurement of that total length. So we take all 3 of those lines there, and then we can see that the total length there is 1.493. Then when we flatten this thing, that's what we should expect to see in the flat pattern as well. Even though these values here are 1.446, we should see that it'll actually end up being these values, the measurement of whatever those values are, 1.493. So if we go here to sheet metal and we go to flatten, and then we look at that length, we can see that it is 1.493. So that's how you can kind of like validate that, or like just kind of like check yourself if you're like, wait, am I really understanding this? Is this 1/3 of the way, or is it 2/3 of the way through? That's kind of how you could do a quick check. You can just model up a couple of little parts like this, and then just measure the sketch length when you take it at that ratio. One thing that I've seen get a lot of people into trouble is they create a bend allowance here using like actual bend allowance or bend deduction that is way off from the actual correct expected value. So for example, let's say I make my bend allowance here 0.0001 millimeters, and I hit the green check mark. So in the form, this looks good. And if we take our K-factor length here, the K-factor length is at 1.493. But if we go into the flat pattern now, and actually this actually just didn't even flatten because of that, I think. Let's see. I think I made it just a little too small for that to. So let's make it 0.01. See if it likes that. Okay, there we go. So in the flat pattern length here, if we were to click on this line here, it comes up at 1.26 inches instead of the 1.493. So where did all of that extra material go? Well, all of that extra material got absorbed into the calculation for flat pattern. Now, in this case, that might be, this is a good example of like where it's really easy to miss, because it's like, okay, did it flatten? Yep. Does it look good? Yep. Okay, let's send it out to the shop. Let's get it cut. Let's start laser cutting it, and then you end up with parts that are way too short. But to illustrate that in a more exaggerated example, let's say I was to create the same kind of a sketch here. This time I'm going to come across here about 5 inches, and I'm going to come up about 3 inches. And then I'm going to do my sheet metal, and I'm going to say that I want my default bend radius here to be a radius of 2 inches. So there's my bend radius. And I'm going to say that I want my bend allowance here to be 90 thou. So what I'm saying there essentially is in the flat region of this bend here, it's 90 thou. That's what the flat will calculate out to. It's clearly incorrect. Like you guys as engineers, you should look at that and be like, that's not right. There's no way that's only going to be 90 thou, right? That's a 2-inch radius. You're taking a quarter of that 2-inch radius. There's no way it's going to work out to 90 thou. But when I go into the flat pattern here, you see, yeah, it looks good. Okay, it flattened. We're good to go. Right. And you can really see that if you go into your flat pattern options, and in your flat pattern options, you say, don't merge the tangent faces together. And then I've got an option turned on here in view for tangent edges. So this is the flat region here. That's it. That's all that's left over. And so if I go back to my formed view, it took that whole length and just shrunk it down. And so the reason for that, again, is because in the definition of the sheet metal, I told SolidWorks, anytime I make a bend, automatically flatten it to 90 thou long. It actually will measure at 90 thou when we go in the flat pattern there. So if I click on this little edge here, let me do it on this side. If I click on this little edge here, and then we look down in the status bar, we can see that it actually measures at 90 thou. And that's the flat region that we specified with that. So again, why would anybody ever do that? Well, normally what you're supposed to do is look at a table and say, if I'm using this material and I'm using this bend radius, then here's what the bend allowance should be. And those tables are very fine tuned by the team on the shop floor to make sure you always get the right amount. But if somebody does it by accident, if they're You know, if they're working with a template that's messed up, then you can end up in a bad spot. And if we just change that to K factor, now we see that the issue is fixed. There's what that region is in the flat. There it is in the formed. There it is in the flat. Looks good. So that's just some real basics of sheet metal. Now let's talk about the different methods of working with sheet metal. There's basically 3 different techniques: the insert bends technique, the base flange and friends technique, and the convert to sheet metal technique. And I do have a YouTube video on this where I really go into a lot of depth on this topic. It's in the section here, live stream tips and tutorials. And there's this 60 minutes live with sheet metal where I go into a lot more detail on some of these things. So if you want to learn more about sheet metal, that's kind of a good place to go. It's a live lecture that I gave at a conference a couple of years back. So you can see here that there's 3 different techniques for sheet metal. The first technique is kind of the old school technique of working with sheet metal. And that is to say that that's the technique where we actually create geometry that has uniform wall thickness. So we create geometry like this. So in this case, I created a boss extrude, and then I did a shell on that boss extrude. So the geometry begins with uniform wall thickness. And then we pick a face that we want to be fixed or held in place, and we go to the command insert bends. So when we go to the command insert bends here, what we can do is we can take this and we can turn it into a flattened model. But we can't do it quite yet. And the reason we can't do it quite yet is because this wall back here is merged together, and this is merged together, and this is merged together, and this is merged together. And so we're not going to be able to flatten that rear wall. So in order to use this tool effectively, you have to have at least a little bit of knowledge of how sheet metal works. And if you do, then what you could do is you could say, okay, this is going to get ripped. So there's a rip option here. This is going to get ripped. And I'm going to actually rip that in both directions. And this is going to get ripped, and this is going to get ripped. These guys are getting ripped. It's only Tuesday. All right, so we're going to go green check mark here. And there we go. There we see that model was turned into sheet metal. Some bends were added in the corners, and this model can now be flattened. So this was the old way of doing things in sheet metal. When I say old, I mean before SolidWorks 2001 came out. So everything before 21 years ago, this is what you had to do. Then SolidWorks introduced the 2001 build, and they introduced this idea of base flange and friends. And so what base flange and friends lets you do is it lets you begin a 2D sketch as an open sketch, a thin feature, if you will. So we could create a 2D sketch like so. Let's say it's 40 millimeters by 120 millimeters. And then we take this bottom line here and make it for construction. And then on the sheet metal toolbar, you've got this command that kind of works like an extrude command in SolidWorks, base flange /tab. And what this command lets you do is it lets you take that sheet metal design, that 2D sketch design, and bring it out into a sheet metal shape all in one single command. So you can indicate what you want the depth of that sheet metal extrusion to be. You can indicate what you want the wall thickness to be. So I'll say that I want this to be 2 millimeters. You can indicate what the default bend radius is. This bend radius is going to be based on tooling that your team has in-house. It's also going to be based on what the wall thickness is. There's a basic rule in sheet metal that says never make the bend radius smaller than the wall thickness. So it should always be equal to or greater than. If you're ever working in sheet metal, if you're new to sheet metal, just don't ever make this number here smaller than this number. You can make it the same, or you can make it larger, but don't make it smaller. Or you typically end up damaging the tooling or actually breaking the material here when you're trying to do the forming. So it's just a basic rule. I mean, all rules can be broken, right? We're rebels here in this training, but it's a basic rule of sheet metal. And you can indicate what the bend allowance or bend deduction or bend calculation is. This is an equation that you can use. So the equation will change based on the radius and based on the wall thickness. You can do what's called a bend table, which is another tool that you can use that'll kind of like auto solve based on the angles and based on the material thickness and the bend radius itself. So there's a lot of different options here, but K factor is it's the easiest. It doesn't mean it's the best, and it doesn't mean it's the most accurate. It's just the easiest. It's the best way to get into the ballpark. And so You hit the green check mark, and now you have a sheet metal part in one single command. So you just started out with a sketch, thin feature sketch, turned it into sheet metal. And then there's all these other cool tools that come with this. Like you can do edge flange, so you can just take this edge here and drag it off and turn it into sheet metal. When you're doing that edge flange, you can see you got these soft relationships, right? Like it's a black line, but if I grab it and I drag it, you can see that I can bring that off. Whenever you're creating sheet metal geometry, you're going to have this option here, which lets you control this option here, which lets you control where the flange actually ends up. So is it flush with the existing material? Is it sticking out one material thickness, or is the entire bend sticking out? So we can say we want that to be flush with the existing material, and that way that shape ends up being flat on that surface. There's lots of cool stuff that you can do, like you can create sketched bends. That's a pretty useful thing that you can do with sheet metal. So I could come in here and create a line, either a straight line or a line at an angle. And then I can go to the sheet metal commands and I can do what's called sketched bend. So I can choose to bend that up wherever that line is. It's kind of cool. You can do what's called a jog, which I think is pretty cool. If I take this line and I put this line here and then I go to sheet metal, there's what's called a jog. So this is kind of like a sketched bend, but it actually brings the material up and then back over. And when you do the jog, you can say that you just want to take this existing geometry and project it straight up. Or you could say, no, I drew it in the flat and I want to bend it up now and remove that material. So if you uncheck this option, you'll get that result from the jog. So there's lots of cool stuff here in sheet metal. I'm not going to go through every feature, but there's lots of cool stuff that you can do here in sheet metal using the base flange and friends functionality in sheet metal. That's what came out in 2001, continued to be improved. And in 2000 and I think it was 2012, they completely revamped the sheet metal functionality to account for multi-body sheet metal. And they updated like a lot of the underlying technology in the sheet metal templates. So there was a couple of years there in tech support when I was working where people's sheet metal designs would get totally screwed up, especially with multi-body. And they would call us up and they'd be like, what is going on here? Nothing works right. And then it was like, oh, you're using an old template. You have to make a new template using the new code. So that was a fun period of time to work in tech support. Here's a final one that I'm going to show you. This is a little bit of a newer school functionality, which is convert to sheet metal. This is a pretty cool thing that you can do with sheet metal. Whenever you have sheet metal, if you have geometry that gets to be kind of difficult, like geometry that flanges out at angles, it can be really hard to just do edge flanges and do base flange and friends to get that geometry to actually line up the way that you want it. So let's say, for example, we had a shape like this that it gets extruded up, but it gets extruded up with draft. So it's extruding up and it's got draft sticking out here. And then one of these sides actually gets lopped off a little bit. So it's got one side that's essentially chamfered off, and reverse direction on that one. And now we're supposed to turn that into a sheet metal tray. So you've got all these weird angles that are coming together, and it's really difficult to do that with base flange and friends. You have to like constantly edit your sketches and change the angle of your sketches, and it's just really difficult to do. And so SolidWorks introduced this super powerful tool called Convert to Sheet Metal, this guy up here. And Convert to Sheet Metal lets you take a solid shape like this and pick a single face and then say what you want that single face to be. So I'm going to say it's going to be 90 thou. Actually, I'll make this 1/8 of an inch. And then I'll say that I want my bend radius to be 0.25. So I'm going to take this one single face and turn this one single face into a sheet metal shape. And so I hit the green check mark, and there it is. You see the rest of the design just went away. SolidWorks ignores everything other than that one single face that I selected. All right, let me Control Z to undo. And I'm going to do this again, convert to sheet metal, 0.125, 0.250 radius. I'm going to pick this face here. Now I'm going to pick this edge as well. And so now something kind of cool is happening. SolidWorks is saying, okay, I only care about this face and this face here because those two faces are connected at this edge. And I don't care about anything else in the design. And when I hit the green check mark, it leaves me with a sheet metal design that I can flatten. And it doesn't care at all about the rest of the geometry. It only cares about, those elements of geometry that were related to or affected by, your features. So now I'm going to go full send here. I'm going to say I want that, I want this edge here, and I want this edge here to all be bent edges. And so now I hit the green check mark, and SolidWorks leaves me with this very nice, completely flattenable, angle-walled shape that would have been really, really difficult to create using the standard sheet metal tools. So anytime you have something, and I know this is a different topic, we could spend time cleaning that up and making that look better, but I'm not going to worry about that now. Anytime you have something that's a weird shape, like this is a vertical hopper here. It's got an angle cut on the bottom. These are all drafted at different angles. So these are drafted at one angle. This is drafted at a different angle. These are different. These are different. You're able just to create that as a solid, then use convert to sheet metal. And then of course, at the end, you can revert back to using your base flange and friends. So if I then needed to take something like this and create an edge flange coming off of it, it's no problem. All of the other tools are still there. And when you do an edge flange like this, you can specify what the angle is, or you can even specify that you want it to be either parallel or perpendicular to an existing face. So I could say I want that flange to be parallel to that bottom face, so that when I create these flanges here, I wonder if I can get multiples in one command. I'm just curious. Hey, I can. That's cool. I'm learning something. Well, that one doesn't look parallel. Oh, that's interesting. Each one of them is
Yeah, it doesn't work if your angles are different between
it doesn't
the
work.
faces,
Okay.
unfortunately. But you can do them individually and it'll work.
Right. Yeah, that's kind of what I remembered from probably from that hopper design. I probably went around the hopper design and ran into the same thing. Okay, so now let's talk about whoops, I skipped one little section here. Let's just talk real quickly about how to create a flat pattern. So here is my sheet metal design that I'm going to be using. Let me just save this. I'll call this box. And now I want to turn this into a flat. I want to have a flat pattern for this. Certainly you can come up here and you can click flatten and that works. But the correct way to make a flat pattern is to create a configuration, because you want to be able to show this in the flat and in the form, for example, on the drawing. And the way to make a flat pattern configuration, the absolute best way to do it is to go File, Make Drawing from Part. You make a drawing from this sheet metal design. So you go File, Make Drawing from Part. Now, at this point, we can see that SolidWorks has created a flat pattern for the sheet metal design. It actually already automatically created a configuration for me. So if I click in the background here and hit escape and close this window, what we can see is there's now a configuration here in the configuration tree that wasn't here before. So I used to only have default, now I have default SM flat pattern as well. And that is the absolute best way to make a flat pattern configuration. Don't get in there and manually do it. Don't just like make a new configuration, call it flat, and then suppress the flatten thing. Just do it with a drawing. Let SolidWorks do it for you. File, Make Drawing from Part. Even if you just do this workflow, if you just go here and then you close this drawing immediately, that's still going to leave you in a way better spot than if you try to manually do it. This is the way to do it. And you want to be careful about working in that flat pattern configuration. You really don't want to be working in that configuration. Maybe you want to open it just to do an export of that flat pattern, but you really don't want to spend a lot of time working in there, because you can inadvertently make changes there that you weren't intending to make. You can just kind of leave yourself in a bad spot. I mean, really, that's the long and the short of it. So, was that?
It looks like a turtle.
Yes, I should have called it turtle part. All right, so now we're going to wind down on the end of the presentation, and we're going to talk about importing sheet metal parts and some of the cool stuff that we can do with the information we just learned. And so there's basically 3 or 4 different scenarios that occur when you're trying to import a sheet metal part. And when I say import, what I mean is you're bringing in a step file or an IGES file, a file that doesn't have a feature tree, and it's up to you and your team to flatten that geometry, to create a flat pattern, to get it out to the water jet, to actually manufacture those parts that you received as imported parts. So the way that we do this in SolidWorks depends on the geometry that we receive. And what I mean by that is if the geometry comes in with uniform wall thickness versus non-uniform wall thickness, and if the geometry has bends or does not have bends, they might, the third party might send you parts that are sharp, or they might send you parts that already have bends in them. So here's what I'm going to do. I'm going to just close everything that's open here, window, close all, and I'm going to bring in this this table. And the first thing I'm going to call to your attention is the fact that the table is opening up in kind of a weird way, in that this icon is displaying. So the icon that I'm referring to there, it kind of looks like the SolidWorks T with a little block, but then it's got a green arrow pointing off to the left. And that's indicating that I'm working in what's called 3D interconnect. Now, 3D interconnect is an option. It's here in your import options. So I went into the little gear up top here, and then I went down to the very bottom here to import. This is all showing up, right? The arrows and stuff I've been drawing. Yeah. Okay. It'd be really disappointing if I found out 90 minutes in that none of that stuff was working. And then here you can see it says enable 3D interconnect. So really quick summary here. Whenever SolidWorks opens something, a file, I'm just going to call it a file, but what I mean is like a neutral file, gets converted Parasolid. That's the SolidWorks kernel. So whenever SolidWorks opens a file, it gets converted to Parasolid. What 3D interconnect does is somehow magically bypasses that process, and it lets you open files while they remain in an envelope or container that does not require that conversion to Parasolid. Full disclosure, I don't actually know how it's doing that. Like, I don't understand the technology behind it. I just know that that's what's happening. And the benefit of that is that you get much faster open times when you go to open up a step file or go to open up an IGES file. And it's also beneficial because you can actually retain links back to the original file, so that if you're working with a third party and they send you, let's say like a Pro Engineer file or Creo file, and they then update that file on their end, they can just send you the updated version, and all the geometry in your assembly can update to that new version of the file. So it's it's actually really powerful stuff, and not many people leverage it to its full potential, but those who do, find a lot of time savings from it. But if your job is to take an imported file and convert it into a sheet metal file and flatten it, it's actually probably better to have this not turned on, because when that option is turned on, you end up with this kind of awkward container file. And then underneath this container file, we have these other kind of awkward container files. And I think you're going to be better off if you were just to open that file using the traditional method, meaning that 3D interconnect is not enabled. So if I go in here to import, you can see that I've unchecked the option for 3D interconnect. And now I'm going to once again bring in a step file into SolidWorks. And this time it takes a little longer to open, because this time it actually is converting it into Parasolid. And this time we see the feature tree looks more like a traditional SolidWorks assembly feature tray. So right away, we've got the files here. We're ready to start working with this thing. So that's 3D interconnect. That's the first part of this lesson on importing geometry. And maybe you want to experiment a little bit with it. But if I was working at a company and I was doing this all day, I would turn it off. I would turn off 3D interconnect. Okay, the next thing is we're going to open up this file here. Open up this file, which is a step file. What we need to do is figure out whether or not this file has uniform wall thickness. And so some of the ways that we can do that are, we could click on this edge here. We could look down here where it says length 3, and then we could click on another edge and see if it has that same length. We could click on 2 different faces. So I could click on this face and this face. That'll definitely work. We could run the evaluate thickness analysis. So we could say like, hey, how thick is this thing? Is it all the same wall thickness? And it actually, whoops, sorry, I clicked through that too quick, but it actually did show me. Let me do it again. All regions of the model have thickness greater than or equal to the target thickness. Okay, so it's basically telling me everything is 3 millimeters. You can kind of hold your mouse over it to see it. So that's another way you can do it too. Probably the most common way that you would do it is you would just run the command insert bends. Like if you look at it and you're like, this looks like it's pretty much uniform. What I would do is I would just pick on this face and I would go to sheet metal. And now we're going to use that old school before SolidWorks 2001 insert bends command, because we have a model which has uniform wall thickness. So anytime the model has uniform wall thickness, that's a good time to use insert bends. That's kind of like the litmus test there. So we click on this face, we say insert bends. We know the wall thickness is 3, so maybe a default bend radius of 3 is good. Maybe we make it a little bit, a little bit larger based on the tooling we have in-house, and we hit the green check mark, and there we go. We took our model, we imported it, and we turned it into a flat pattern. So that's lesson 1 on importing geometry. What do you do when the geometry has uniform wall thickness? Now, lesson 2 is, what do you do when the geometry has non-uniform wall thickness? So here you can see that we've brought in this model. This model has come in, and clearly this is non-uniform wall thickness. So we got this tab over here that's thicker. So if we click on this face here and we do insert bends and we say, okay, 5 millimeters, that's good for the bend radius. This is what ends up happening. So those areas where the wall thickness was non-uniform just disappear, and then this area over here in the tree will probably throw up some kind of a warning or an error. It can still be flattened. You can still hit the flatten command, and you can still, right mouse button and do export to DXF DWG, and then export a flat pattern right from the, right from the solid. That'll all still work fine, but it's not what we wanted. Obviously, it's not what was intended from the customer. So in those spots where you try to flatten it and you end up getting a problem like that, this is a great time to use the convert to sheet metal functionality. This is the one that I told you about when you have like the weird angles, but it's also really useful in this spot. So I could say convert to sheet metal, and I can pick this face here as my primary sheet metal face, or maybe I want to pick the outside face. It just depends kind of on what you know about the project and which dimensions you know to be critical. So I can pick the outside face here as well. And then for my bend edges, I can pick this edge and this edge. And what SolidWorks is doing here is it's not calculating this thickness based on the existing wall thickness. It's calculating it based on whatever I'm putting in here. So if I put in 2 millimeters, that's what it's going to give me. It doesn't care at all about what the existing wall thickness is. It only cares about the base face that I selected, then the edges I choose to bend. So let's say I make that 3 millimeters. That's what I want it to be, and I want it to use a 3 millimeter bend radius. And then I also say I want to pick this edge, and go around and pick all the other edges. You can see what the result is. So before the convert to sheet metal, I had that weird non-uniform wall thickness, but after the convert to sheet metal, I just have the desired results. And then I would have had to pick those other faces over there, but now from here you can see I can do flatten, and that flattens that out. Cool?
Cool. Yeah, man.
Cool. All right. So now let's take a look at this final scenario, which is they shipped us a model and the model already has bends in it. It's uniform wall thickness, so we're still going to use insert bends, but we need to look at what these bend radii are and see if they're actually going to work for us. So when I click on this edge here and look down at the status bar tells us that the length is 3 millimeters. When I click on this radius here and I look down here, we can see that the radius is 1.5 millimeters. So that's probably going to be a problem, just from our basic rule of not having the radius be smaller than the wall thickness. Now, the default behavior in SolidWorks is if you have an existing tangent-tangent relationship in your geometry, then SolidWorks is going to honor that existing radius when it goes to create a sheet metal design. So for example, if I created just a regular solid model here, this is not sheet metal right now. If I just created a regular solid model here, and then I click on this face and I say insert bends, and I say I want my default bend radius here to be 1/4 of an inch, and then I hit the green check mark, SolidWorks doesn't change this radius. So this radius here is still radius 2.704, because that's what it was when I started the command. It just looks at the existing geometry and uses the existing geometry. It creates what's called a round bend. So here's the round bend in the tree. But if I create any new geometry, like if I click this edge and do a new edge flange, that's going to honor the 0.25 bend radius that I input when I was creating that geometry. So what that means is if we come over here to this design and we measure this design, and we find that the wall thickness is 3 millimeters. And so we click on this face here and we say insert bends, and we say we want that bend radius to be 3 millimeters so that it matches the wall thickness. Well, SolidWorks isn't going to go and change this value. It's already 1.5. So if we hit the green check mark here, you notice that stayed at 1.5. But what it will do is any new bends that I create, I make a new bend here like so. That new bend is going to have a bend radius of radius 3. So what do? Right? We got this model from the customer. We could go back to the customer, right? We could say, hey, dum-dum, you can't give me that model with those radius. Can you just get rid of those radiuses or make them bigger? Right? We can definitely do that. But the other thing that we can do is we can use the command insert face delete. And insert face delete is one of the most powerful commands in SolidWorks, especially if you're working with a lot of imported geometry. Because what insert face delete lets you do is it really does a surfacing type of a command. And what the surfacing command is it's take this face and extend it down in this direction, and take this face and extend it over in this direction, and then remarry those two faces together. So if I go to insert face delete, and then I pick on this face here, and I say, and I'm going to use this option. We're just going to focus on this option, delete and patch. That'll do the functionality I described a moment ago, where it extends the faces and remarries them together. Insert face delete, hit the green check mark. There we go. It leaves us with a nice sharp corner. And so what we could do here is in one single command, we could go around. You probably, usually with sheet metal, at least in my experience, you have to do it in 2 steps. You have to get the outer radii and then the inner radii in order to make sure that the inner radii don't end up poking through when they're a sharp point. But like on this model, I actually probably could do it all in one single step. So we go through and we get all those and turn all those into sharp corners. And then we just repeat the command. I use delete face so much that it's on the S key. I customized my S key in feature mode and added delete face here to the S key. So delete face again, delete and patch. And now this time we'll just go through and get those inner corners. There's probably an easier way to do this, like a filter or something, but usually I just brute force my way through stuff like this. So whenever we do delete face, these faces here are going to be extended. I'm going to hit the green check mark, and there we go. That gives us a sharp corner. And now we can revert back to the scenario where we've got uniform wall thickness. So we could do insert bends, say we want a radius of 3 millimeters or whatever it is that we want. And now it's going to give us the proper 3 millimeter radius for all those corners instead of the 1.5. So if the customer, depending how well you know the customer, you could maybe just go back to them and say, hey, can you give us this as a sharp, or give it to us with the radius for the tooling we have in-house? But if you don't know the customer, or if you just, you can just do it quicker yourself, then send them an email, wait for them to get back to you. That's how you could do it. And then, of course, this can be flattened. And then, like I mentioned before, you could do a right mouse button and export to DXF DWG. And then, flat and give it a name or whatever, and say you're going to do this as sheet metal because you want to get the sheet metal stuff. And then if you want the bend lines to come in, you can get them to come in too. And then SolidWorks will even give you a little preview here of what that flat pattern is going to look like. So that is just a little bit about sheet metal and delete face and importing sheet metal geometry and kind of things to look out for. One last thing I just want to say about delete face that's definitely worth knowing is that it's great for holes. So if you have an imported model that has holes, you can use delete face in those spots too. So you just go insert face delete, and then you're going to pick this face to delete, and then SolidWorks is going to extend or untrim these other 2 faces on the top and the bottom. And there you go. Now you got rid of that hole. So if you ever have geometry that you imported that you need to get rid of, delete face is definitely worth learning about. It's a great time saver.
That works similar to like direct editing, right? That's kind of the same features as direct editing.
Yeah. Like move face, all the move face commands, delete face. Yeah, they're all in that same bucket of rather than editing the parameter that's driving the geometry, you actually just blitz the geometry a different way. So that's 3D interconnect using insert bends, using convert to sheet metal, using delete face. that's the 3 topics we talked about for sheet metal. I want to say thank you all so much. If you have any questions, this is the stuff that we went over tonight. I hope that you feel like you're experts on all 10 of these topics now.
Absolutely.
Okay, good. Then the class was a success. Don't forget to check out SolidBox. They got lots of good stuff. If you check out their website, there's a section on their website for products, and it shows the different configurations that they offer for the different computers. Great company, run by a great group of people, and definitely worth checking out. They offer a lot of different services, but this is like where I usually hang out, is in the different types of computers that they offer. And I think that's it. Check me out on YouTube. You can get some good tips and tricks on YouTube. Great community on the YouTube. I do a lot of live streams that are kind of like user groups, like digital user groups almost. And the chat is really funny, and everybody is interactive in the chat, and it's a good time in there for sure. Anybody got any questions?
No, I don't think so.
I'm pretty good, man. I appreciate it. Thank you greatly for doing this for us.
No, thank you for setting it up. I'm honored to be here.
So I'm sure you can use some more YouTube subscribers too. Yes.
Absolutely. Yeah. Always trying to grow the YouTube channel.
Yeah. Okay.
Yeah. Thank you.
Do you have anything out there on the YouTube channel as far as, like, say, weldments and surfacing?
I got a really, really good surfacing presentation on there. Some of my best work, I'm going to say. It's this one here, beginner surfacing for beginners. It really, really helps people who are just getting into surfacing to understand the fundamentals of what surfacing is and how to use it, and really get you started on the right foot. I also did one where I created this. I think I did this one too. Yeah, the skateboard deck I did as a surface also. So using photos and then creating the skateboard deck. So yeah, those are both really good surfacing ones. I don't really have anything on weldments yet. I know a lot about weldments. I've taught a lot of classes on it. So it's definitely something that I can, and I'm sure will, put together some content for. I just don't have anything out there right now.
Thank you very much, man. I greatly appreciate it.
Yeah, my pleasure. And one of the user group presentations I have in my back pocket is talking about the new structure system and kind of comparing that to weldments. So structure system came out probably like 2016, 2017, around then, maybe even 2018. But I put together a presentation that I think does a great job of showing the difference between the structure system tools and the traditional weldment tools. So if you guys ever in the future do a user group and you want to have me back, that might be a good topic that we could do.
Okay.
It's definitely good for me because it's already put together.
Yeah, there you go. I'd definitely like to have you back.
All right, awesome. We'll make it happen. Maybe even in person. Maybe I can come down there.
Yeah, that'd be nice. That'd be awesome.
Yeah, you could even drop by on your way to Texas.
Yeah.
I know it's only a month or so away, but
yeah.
Or the plant while you're here.
We can definitely figure something out. Yeah.
Yeah, well, we'll talk about it a little bit. We'll see what you got, what your plans are the way, and see. I mean, for real though, like if you got something that we'd be interested in, we could do it again in a month, but with you here,
Okay. Yeah, we'll see how it goes. I mean, that trip is starting to get already booked up.
Oh, I'm sure. Yeah.
But definitely in the future, and if we can make it happen on that trip, that's great. So yeah, I'm up for whatever. I'm sure we can talk about it more too. And don't forget,
of course, yeah.
James is going to be the big star on Saturday during the live stream. He's going to be co-commentating with me on that head-to-head matchup. So be sure you guys tune in for that too if you want to listen to us nerding out on CAD on a Saturday morning.
Yeah. It's the adult version of Saturday morning cartoons when you were a kid.
Yeah, exactly.
The adult CAD version.
Yeah.
Well, cool. I appreciate you, Toby.
All right. Appreciate you as well. Thanks, guys. Nice seeing everybody. And I'll see you guys again soon, I'm sure.
Appreciate it.
Thank you.
All right. See you.
Hey, too bad.
Yeah, a little bit over. Yeah, a little bit.
Over or under? I know one thing. I think it's still me another cookie.
Don't take some boxes.
Yeah, I will.